Okay, YouTube, in this video we're going to continue solving oblique triangles, but in this case using the law of cosines, and this is the second particular instance that I want to look at when solving a triangle with law of cosines. It is either a side angle side case or a side side case, which is what we're going to confront in this video here. So really quickly, let's go ahead and sketch up what we might conceive of our triangle looking like here. We've got two similarly lengthed sides, and one with a short or a longer length than those two, quite a large amount longer. Okay, so we say that maybe this is our 20 over here, and we're going to call this lowercase b, and we could say that this is our c right here. Oops. Actually, we should call this one c. It's the shorter of the two. We say c is 18, and then b is 20. So knowing this, we could say that this longer side down here now would be our 18, or 34, pardon me. And this would be our lowercase a. So we have uppercase a across from this, uppercase b across from this, and then uppercase c across from this. What we want to do is go solve for the parts of this triangle, but you'll notice that in this particular instance, we just don't know the angle. So as far as using the law of cosines, recall it starts off very Pythagorean-like, so we have a side squared equals the sum of the squares of the other two sides. And then we have always minus 2 times the two sides you just had right here that you had squared and summed, and then times the cosine of the angle that corresponds to the side length you started with. So in this particular case, if I'm going to solve for anything, I'm going to solve for an angle, and that comes at the end of these formulas. So when we work through this, don't think that this is pretty Mickey Mouse, because we get a lot of people make mistakes with the idea that, this part right here you could look at, as it's the coefficient of this cosine of this unknown angle, and people always try to subtract it from the sum of these squares first. So we're going to look at this case and say, let's solve for angle A. I will give you the recommendation to use angle A because it's the biggest, and it's usually sometimes you'll find a triangle that doesn't work, and you'll always know if you check the biggest angle first. So in this particular case, I would say that, well, this is the law of sines form of the formula that I'm using. So minus 2bc cosine of a, and I don't know the a. I should know everything else. So I have this squared equals these squared and summed, minus 2 times those exact same quantities, and then we have cosine of some unknown. So in this particular case, we have a. A is 34. We're only going to fill that in once, and these two just become the 18 and the 20. Respectively, 18, 20, 18, 20. Okay, so important facets of this. We're going to go ahead and square out our 34 on the left. So 34 times 34, that is 1156. So we have a 1156. 18 squared, I think that's 324. I should know this. 18 squared, 324. So we have 324. So 324 plus 400. Minus now 2 times 18 times 20 is, this 2 times 18 is 36, double that is 72 with a 0. So this, you need to multiply that first. It is, like I said, it is the coefficient of this cosine of a, and we need to isolate this. So first things first, this is how you solve these. You always need to glue those two terms together first. So we have 724 minus 720 times the cosine of a. Just to be clear, you must subtract this constant out first before you deal with this negative 720. You cannot combine those. This has a coefficient, value on it. I guess the cosine of a is the coefficient of 720 if you want to look at it that way. And this one doesn't. It's a constant. So subtracting this out, we get this. We get on the right negative 720 times the cosine of this angle A, and that is equal to, and I'll use a little help here, 1156 minus 724 is 432, and that's positive. So now we're going to divide both sides by negative 720, which causes this to be a negative here, it seems. We have the cosine of a is equal to this right here. We'll just do the cosine inverse of both sides. We get a equals the cosine inverse of this 432 over 720, the whole thing being negative. And so we'll go ahead and do this on the calculator. So we have 432 divided by 720 equals, and of course it's negative. And, ooh, that's nice, 3/5. Okay, so we say cosine inverse, and we get about 126.9 degrees. So A is approximately 126.9 degrees. So now, just like with any situation where you've solved for an unknown on a triangle, go fill it in. And also this, just to point this out, we have A is 126.9 degrees. Lowercase a is 34 degrees. So now we have uppercase B and uppercase C to solve for, but the whole point I want to drive home is this. We certainly know that B is 20, this C is 18. You have a side angle pair now. And so what I'm suggesting is this. go use the law of sines now to solve for these other two values, because the law of cosines, while really not that bad, is usually a little bit more extensive than the law of sines. So go ahead and use the law of sines to solve for these other two unknowns. But that's how you use the law of cosines in a side case. Cheers.